Memory design. When we talk about memory, what we mean is computer chips that store things like programs and the data that's in the PLC. And the more memory that you have, the bigger program, the more complicated program you can have. And the amount of memory on a PLC typically depends on what the PLC comes with. Most of the time you can't add memory to a PLC. So the amount of memory does limit the quantity of stuff you can do, the complexity that's available. Now, the memory location talks about exactly where a particular address in the memory is located, where information can be stored. So, of course, it's always made up of bits and bytes and then words. You can even break up the byte into two parts, each called a nibble. And of course, ones and zeros are used in each of these bit locations to assemble an entire 16-bit word. Now, in some PLCs, you can have one memory address where you can either address it as a word, as a byte, or as a bit. Now, that's not true of all PLCs, and the click PLCs are an example where you can't address, say, one bit of a memory location that is supposed to be a word. At least I haven't found out how to do it yet. I don't believe it's possible. Now, it's important to realize that besides all this memory that stores, the programs and then whatever data the programs need in order to work properly, some of that memory is sort of special area. And so there's an input table, for example. There's an area of memory that's reserved just for memory addresses that are associated with input, so that when you have a particular input to an input module turns, say, on, for example, or is passing power, then a 1 is put in a very particular bit associated with that particular input. On the other hand, any other input that is wired to one particular point on the input module goes to a different bit. Now, in some programming languages, some PLCs, you can reference the entire word or you can reference a particular bit. In the click series, typically the X's are inputs, and so X's are always bits. So X1, for example, is just a bit, or X101 is a bit. And you can't reference, as far as I can tell, an entire word of data from an input module. In other words, you can't just grab all of the inputs at once. Technically, the PLC already does that. Every time it begins a scan, it just looks at what all the inputs are doing, and the way it does it is by going to memory and looking to see whether there are ones and zeros in each of the places that correspond to the input devices. Of course, in your program, you tell it which ones you actually care about. It'll copy the whole input page, if you will, but it only references the particular ones that your program needs. So if you have a blank program, it doesn't reference any of them, right? It copies them, it doesn't reference them. So the way this memory works, though, is that whenever in the real world a switch is closed or opened, in other words, whenever that terminal has current flowing through it or changes where current's not flowing through it, the status of the bit associated with that particular input is updated automatically. That's just the way the circuitry works. So that's the reason that PLCs are so convenient for having inputs, because there's particular memory already set aside so that any input you have will automatically flip a bit. So when you're closing a switch on the PLC, you're flipping a bit in memory. You're just doing it manually, basically. Now, the output section is another file or table or page, if you will, of memory that similarly is associated with the outputs. And the way this works is the circuitry in the output module is constantly monitoring this particular memory address, these outputs, in order to determine whether it should pass power to the output devices or not. In other words, whether it should close the circuit at that particular output. And so it's really important to understand that inputs from the last slide turn on and off memory bits, but in the input memory page. But outputs are driven by memory in the output page. So the PLC, basically, the code, your program, what it's really doing is grabbing the input page, looking at all the inputs and performing logic based on what you've designed your program to do, and then the results of that program, the calculations of the output, get written into this memory page by the PLC's program, the program you wrote, and that's what then turns on and off the various outputs. If there's a 1 there, then that output is on. If there's a 0, then that output is off. So it's a simple system, but of course it's got all the circuitry set up so that this is ready to go, and it makes inputs and outputs to and from PLCs very easy to connect and to use. Now on the Click PLCs, for example, Ys are outputs, and on other PLCs, Allen Bradley in particular, often you can reference an entire word of outputs, which can be very handy. Again, I have not found a way to do that on the Click PLC either.